Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Jr., your math tutor and instructor of mathematics at the University of Liberia. In my today's lecture, I will be looking at the third example under variable separable. So we told you that when you have a differential equation and you have a case wherein the variables can be separated, that is, all x can go one side of the equation and all y can go one side of the equation, you can apply variable separable to find the general solution of that differential equation. So we solved the first two examples. We'll look at the third example. So the problem says that we must find a general solution for this first order and first degree differential equation. Y minus x dy by dx equals to a times that's a y squared plus dy by dx. So we first multiply this a by each term in there. We have y minus x dy by dx. And then we multiply this. We have a y squared plus a dy by dx. Okay. So remember, our goal is to ensure that we have all of the variables in y to be one side of the equation and all of the variables in x to be one side of the equation. So if we clearly see you have this term and this term, you can group them, right? And then you can group the other one. So if I group this and this, I have y minus a y squared equals, if I send this one across, I will have a positive x dy by dx plus a dy by dx. So this one now, I factor out y squared. I'm left with 1 minus a equals. Now, dy by dx is common to the two terms, so I can factor out dy by dx. So this is out. I'm left with x in this term, and I'm left with a in this term. So I can multiply this entire expression by dx to get rid of the x from here. So if I multiply this by dx, what will I have? I will have y squared times 1 minus a dx equals dx times this is just dy. So it's x plus a dy. Right? So now we have our okay. So we need all x in here and we need all y in here. So this y squared, we can divide both sides by y squared. Divide this side by y squared. Right? And the next thing is that this x plus a, we don't need x plus a yet because this is all y. So we can divide both sides by x plus a as well. So this and this will go out, whereas this and this will go out. So we'll be left with 1 minus a all over x plus a dx equals to dy over y squared. So the variables now have been separated. We can integrate both sides. So this 1 minus a is a constant. So we can factor it out. Remember, it's a constant. So if we bring it outside, we will have just the integral of 1 all over x plus e dx. Then we also have the right hand side to be the integral of y to the power minus 2 dy. Now we know that the integral of dx all over x plus some arbitrary constant is just equals to the ln of x plus some arbitrary constant c. So this is in similar form. So this is just the ln because this is a linear factor. So this becomes the ln of x plus e equals, now the integral of this one now, the integral of, what is it? X to the power n dx is just equal to like adding 1 to the power and dividing it by the new power. So we add 1 to this power, we'll be left with minus 1. So now the only time you cannot send the power in the numerator when this denominator power is 1. If this was y to the first power, then we wouldn't have sent this power in the numerator because there is a notation that says that states here that right here for this property that n should not be equals to minus 1. So if it was positive 1, we wouldn't have sent it up, but because it is 2 above, we can send it up, or even below, we can send it up. If this was like minus 1 down here, we can send it up. Minus 2, we can send it up, but it can't be positive 1. So we add 1 to that power, it just gave us y to the power minus 1 plus some arbitrary constancy. So we're done now. It's just to solve for y. So we know that if we take the reciprocal of this y, we get a positive y. So we have 1 minus e ln of x plus e all equals to 1 all over y plus some arbitrary constancy. So if we say let's multiply this whole thing by y, what do we get? We will get y times 1 minus e ln of x plus e equals 1 times, let's say y times 1 is just y cancel. So it's 1 plus, so this is cy. So the next thing now we can divide this out by this expression and divide this out by the same expression, 1 minus e times ln of x plus e, 1 minus e ln of x plus e. So this will cancel this one. You have y now to be equal to 1 plus, now this cy, you can just say c, or we just maintain it as cy, but you can just say c, it's just c. Now, divided by, remember we told you r ln of a equals to ln of a raised to the power r. So this whole factor represents r. So we send it to the power. So it becomes ln of x plus a raised to the power 1 minus a. Right? So this is our final answer. So remember, you could just stop right here. You could just reciprocate this one and just stop right here. You know, not most times I like to solve or simplify the problem in its simplest form. So don't mind me. Just stop where you can stop or where your instructor asks you to stop. Thank you very much. Math is fun. Let's have fun always. Thank you. See you in our next lecture.